In today's video, we're going to cover relative formula mass and look at the sort of calculations that you might have to do. If you remember from previous videos, we can find the mass number of any element by looking in the top left corner of its nuclear symbol. And this tells us the number of protons plus the number of neutrons in its nucleus. Sometimes though, the nuclear symbols will show the relative atomic mass instead, which is the average mass of all the isotopes of that element, and is denoted with Ar. So whereas particular chlorine atoms could have mass numbers of 35 or 37, chlorine as an element has a relative atomic mass of 35.5, because that's the average mass of these two isotopes when we consider how common each one is. But what if we want to find the average mass of an entire compound, which will obviously have more than one type of element in? Well, that would be the relative formula mass, which we always write as Mr. To find it, all we do is add together the relative atomic masses of all the atoms in that compound's molecular formula. So if we took magnesium chloride, which has the molecular formula MgCl2, we'd have one magnesium, which has a relative atomic mass of 24, and two chlorines, which each have an Ar of 35.5. So we'd do 24 plus 35.5 times 2, giving us a relative formula mass of 95. Or for sulfuric acid, which is H2SO4, we have two hydrogens, one sulfur, and four oxygens. So 2 times 1 plus 1 times 32 plus 4 times 16, which gives us a total of 98. So the Mr is 98. You could also be asked to calculate the percentage mass of a particular element in a compound. For example, we could find the percentage mass of sulfur in sulfuric acid. For this, we do the Ar of the element we're looking for times the number of atoms of that element divided by the Mr of the compound. And then we multiply it all by 100 to turn it into a percentage. So here we would do 32, which is the Ar of sulfur, times 1, because there's only one atom of sulfur in sulfuric acid, divided by 98, as that was the compound's relative formula mass that we found a minute ago. This gives us 0.327, which we then times by 100, giving us our answer of 32.7%. Before we finish, let's find the percentage mass of oxygen in calcium hydroxide, which has the formula CaOH2. The first thing to do is to recall our formula and check the periodic table to find the relative atomic mass of each element. So 40 for calcium, 16 for oxygen, and 1 for hydrogen. So for the top of our equation, we need to do 16 times 2, because we have two oxygen atoms. Remember, the 2 after the brackets applies to both the oxygen and the hydrogen. Then to work out the Mr, we do 40 for calcium, plus 2 times 16 for oxygen, and 2 times 1 for hydrogen. So if we simplify it, we get 32 divided by 74, which we times by 100 to give us 43.2%. And that's all for this video. So hope you enjoyed it, and we'll see you next time.